Okay, now that we've gone through the trouble of talking about the OSI model, the fact that there are 7 layers, we now come into the limitations of the OSI model, right? Now, first of all, the limitation that's most obvious is that there's 7 layers, and the experts, by the time the 80s rolled around, said that that's too many layers. And the ISO staff in, I believe, Switzerland at the time, the ISO, they're used to regulating all kinds of things in all walks of life, if you will. And the OSI model was just one of the many things they were working on. And technology tends to run its course fairly quickly. And the idea is that, as technology progresses, as does the inventions that capitalizes on those, I guess you could say, initial inventions. We can look at the OSI model almost like giving birth. It's kind of like they introduce the world to these various layers, and the knowledge, like giving birth, it starts in infancy. And as people get educated, as academics, the academic programs improve with their technology. For example, the birth of Unix and all the Unix-like systems, like System 7 and the original Solaris, which was really the first universally understood retail available version of Unix. Things were more popularized, and the problem is opportunities came because people's tastes and expectations changed. And I'll give you an example. Look at me. I was born in 1971. I did not even get, and my generation didn't even get full access, 24/7 live, always on access to the internet till we were, and I'm looking at my brethren, my generation, 1971. We didn't not even get access, home access. Till we were in our probably late 20s, early 30s. Can you believe that? The average age of the folks that are watching this video are probably in early 20s, and you grew up with always on access to the internet. All you have to do is look in your hand and you see the cell phone. Okay? So what I'm saying is that 7 layers, and the exam, and the fact that there was that the really the network layer was useless, because really there weren't a lot of business use cases at all for sharing, information across country. Okay, there was ARPANET. Okay, but it was okay. But anyways, I just when it comes to the 7 layers, they proved to be kind of slow on the draw. So using OSI model as a point of reference, you had about 40 or 50 volunteers at the Department of Defense, and they came out with the DoD model, also called the TCP-IP model. And if you can imagine what the TCP-IP model was, you had 7 layers. So the first 3 layers of the OSI model were application, presentation, and session. Okay, so imagine, if you will, they could be represented by 3 distinct layers. So let's say, for example, it starts off with the application layer by the white book on top, and then we have presentation and session layer. So what happened as time wore on, and as the actual applications got more, I'm going to say, complex, and they got more just giving they had more abilities when it came to define the next, OSI model, like the next generation of the OSI model. They literally took the top 3 and they combined them, mushed them into one layer. Okay, and they just called the application, presentation, and session layer, they just call that the application layer. So what they did was they said all the presentation and session layers, that's all going to glom and combine into this one layer. So the first layer of the TCP/IP model is the application layer, and then it goes right to the network layer. Okay, so so what was started off as the initially 7 layers of the OSI model, it has now been glommed into 4 layers. The first layer being application, which combines the application session and presentation. So imagine it goes application as one, the network layer as the next, or the excuse me, the transport layer, because we went from application to transport. So you still have your UDP and TCP packets, and we have interesting enough, instead of calling the next layer the network layer, which rightfully should be if we were going by the OSI models of reference, they don't call it the network layer. They simply call it the internet layer. Okay, and then the final layer, okay, is what they call the network access layer. Okay, and the network access layer combines the MAC address, the data link layer, and the physical layer, and they simply call it the network access layer. So the OSI model has gone from 7 layers to 4 layers. Okay, and they called this new model the TCP/IP model. So we go from using the OSI model, the 7 layers of the OSI model as a reference, to the TCP/IP model, which uses 4 layers. And one of the key differences is they mushed the application presentation session layer into one layer, and then they considered that bottom layer, the network access, kind of like a mushing, if you will, my favorite word of the day, I guess, a combination of the data link and the MAC address. So what does this all mean to us being malware hunters, if you will? Hunters of the jungle. We want to be king of the jungle, right? So what does it mean for us? Well, the reason why the TCP/IP model has won, between the battle, we can't see that it won because we're still talking about the 7 layers of the OSI model years later, right? So the value of the TCP/IP model, or the DoD model, depending on what you want to say, the value is it did birth us the IP address, but more importantly, it has given us more, I'm going to say, artifacts to deal with. Now, when it comes to malware hunting, okay, a lot of times, we're going to go through more C stuff today, C programming stuff. Nothing wrong with that. And we're going to go through some assembly stuff today, looking at some assembly mnemonics today, right? But the real beauty is that is we can go through all the ASCII code and the mnemonics of assembly code and all that, but unless we wrote the code, we're never going to know exactly what the malware will do unless we unleash it in a very, very safe environment. We call that dynamic analysis as opposed to static analysis. But the issue with dynamic analysis is it's kind of like the old black box theory. There are some, for example, functions that if we stare at the syntax, we're not sure exactly what it does until we begin to give it input and examine what its output is, if you understand what I'm saying. So, it's a deal with dynamic analysis, right? We are not able to see what the malware does until it's actually getting used. But the question is, once it gets used, what is the value? What is the value of what we see? How would you be able to define to tell and communicate to someone else that this is what it's doing? If they ask you, how do you know it's doing this? Like, for example, if it says, I feel it's I feel that if we execute this malware, it's going to send a broadcast to all the other, all the other computers, on this subnet. And they're like, well, why do you say that? Well, through the wonders of artifacts, that we can actually prove it. But what artifacts are available to us? Well, one example is Wireshark output, which we introduced last week. And the Wireshark output will actually show that the piece of malware is going to have the computer send out a broadcast, which it wouldn't have otherwise have done. And that's an example of an artifact that we can see. So the advantage of the TCP/IP model is it is relating each layer to a particular artifact, okay, that malware can produce. And the beauty of Wireshark is that it can show us visually the impact of that artifact. Okay, thank you very much for watching this little micro lecture.